Lead is a soft, malleable metal, which means that it can be shaped easily into complex shapes. This can be done in two ways: by bossing and by cutting and welding. Bossing is a traditional technique used to shape lead before welding had been invented, and is still used extensively today. Unlike other metals, lead does not harden when it is worked and is self-annealing at normal air temperatures, which means that it's unaffected by being worked and doesn't become hard or brittle. When lead is bossed, it's correctly dressed into the required shape without a reduction in the thickness of the lead. The tools required to do this were traditionally made of hardwood, but have gradually been replaced by tough plastic alternatives. It's possible to boss a single sheet of lead into complex shapes such as pipes and hoppers without thinning the lead sheet. It's important to remember basic principles for bossing techniques. In order to move the lead evenly and in a controlled manner, the lead sheet needs to be supported on both sides of the material. There are two principal bossing techniques: preparation bossing and in situ bossing. Preparation bossing is used for the preparation of lead bays, incorporating wood cord rolls, where the lead worker needs to prepare the shape of the rolls from flat sheet, and also bossing an internal corner. This is done with two bossing tools by forming most of the detail out of position and then offering it up and finally completing the process in situ. In situ bossing involves the dressing or a roll end, external corner or overcloak drip detail, and involves only one dressing tool at a time. This technique uses the support of the structure to dress the lead, allowing an even and controlled technique. Good bossing is achieved when the lead is worked to the required shape without creasing or cracking, or without thinning the lead by more than 25% of the original thickness. When bossing thicker codes, it's common practice to use heat during the bossing process, which makes the lead more malleable. This requires the heat to be directed in the locality of the area to be bossed, and requires experience to avoid it being overheated, which can melt the lead and reduce its thickness. Treat this with caution, as this will also require a hot works permit on site. Lead welding or lead burning is used where bossing may cause excess thinning of the lead, or simply where the time available is limited. Welding is not a substandard solution to bossing, as it provides an equivalent outcome but may be preferred to bossing in some situations. Good welding is achieved by a series of simple steps, which includes ensuring that the surface is being welded and the filler rod have been cleaned to remove any oxides on the lead surface, and should be scraped to expose the silver core. Lead welds should penetrate the sheets fully, and also be between 1/3 to 1/2 thicker than the sheets being welded. The welds should have a minimum width of 10 mm for code 4 lead, which should then increase further for thicker codes. There are two principal welding techniques: non-positional and positional welding. Non-positional welding is where the lead worker fabricates a lead component on a bench out of position. This usually involves butts welds, and due to the fire risk that this creates, it is recommended that this is completed out of position. Positional welding is carried out in situ, as there's no other way of fabricating it. Any on-site welding must incorporate a lap joint to minimize the risk, and would normally be used on an internal corner or roll end. The quality of the welding reflects on the overall quality of the lead work. Always look where possible to weld lead on a horizontal surface, as this is the most effective way to do this. Position the sections of sheet and apply tack welds to hold the sections in place during the full welding process. The welding torch and filler rod are positioned so that the cone of the flame is marginally clear of the lead surface. Closer inspection shows that the filler rod is melted and forms a bulb of molten lead, which then cools, forming a dimple on the surface of the weld, which must be covered by each subsequent weld along the seam. Problems can arise by either overheating a weld, the weld quality, as well as the weld colour. In this example, we've butt welded code 5 lead. Thinner codes of lead can be susceptible to overheating, which can cause the undercutting or thinning of the lead locally, which can tear over time. Thicker codes of lead are not as susceptible to this, but to attain the 1/3 to a half thicker weld than sheet lead, it may require the welder to provide a double layer of bead along the seam. Creating the right flame for welding is of crucial importance. To do this, you need to set a neutral flame, which is best done by eye. So with the acetylene lit, turn on the oxygen so that the inner core of the flame has a rounded tip. Too much oxygen creates an oxidizing flame, which is blue in colour, whilst too much acetylene creates a dirty yellow carbonizing flame.